All right. No questions then? Everybody's got it?
I would like to go over, like, for the packet tracer. Are we
Okay.
talking about the packet tracer today, right
Yes.
now?
Let's talk about that.
How do we configure the routers with the CLI? Because I got completely lost on that.
Okay. So let me just share my screen and down here, let me run packet tracer and
You haven't shared your screen yet.
share. There we go. Let me launch packet tracer then. It'll come up. Then we can go over the how to get to the CLI and how to configure things in the CLI. And yeah, you're right. We only really just talked about that. Here's the final file here. So if we got this, if you want, because it actually boots and everything is orange here. You see it's not, the switch is not in forwarding mode. It's actually booting and coming up, going through a real-time, boot process. The wireless, you can see the wireless lines now to the access point, connect. These are still orange, so it's not in packet forwarding mode there with that switch. This router is booted and has an up connection there with the serial connection. And if you go into the router, you've got the ability to go into the CLI, which is right here. And in this case, here, just click inside and press enter. So enable gets you into enable mode. Show running config. And you can walk down through and look at the information that's in your router. You've configured your fast Ethernet port and with the 100.1 and so forth and 255.0 mask. And as you go through this, your serial connection here is your IP address. And this part right here, this router EIGRP 100 network, I'm sharing the 10 net and the 192.168.100 net. That part has to be done at this CLI. Control C and then config T or config from the terminal. And then you would go into router EIGRP 100. And then from there, you can add in the network 10.0.0.0 or network 192.168.100.0. And they automatically added the auto summary for us. But those things are not possible. This little spot right here, it's not possible through the config, because you go to the config and you go down to routing. Well, you only got static, but you can put a static route in, or you can do routing information protocol, RIP. And so there's no EIGRP option to add in those two networks to share them. And so you have to go to the CLI and to do this router enhanced internet gateway routing protocol. And we're going to talk about that more today, but the only way to add that, so it's possible to add it, but through their little config thing, which is Cisco's little they just gave you the basics here, right, to configure stuff. It's not like their normal GUI with their router GUI management product, but just Packet Tracer gives you the bare bones to get everything up and running and get it working. So is that what you were referring to?
I guess, because that wasn't, when I checked my router, that wasn't there because I haven't changed it using the CLI.
Uh-huh.
So how do we add that? Is that all we need to add to these routers as well?
I think
Well,
he's
with
talking about
the,
adding the serial interface.
yeah. So we have the serial interface.
Because I tried like the WIC, I added the WIC1T to the router at one point, but then like I hadn't changed anything in the CLI, and then just the router just stopped working.
Yeah. If you add something, yeah, you just have to turn it off, that little off button right there on the right in the physical view. And then you know, add that, like if you were adding this, you can add this one. But I added this one, WIC2T.
That's the one I think I did copied from the
With,
video.
okay. So you drop that in there, right? You drop it in kind of, and then you power back on, and then you have, once you go to that, when you go to your show running config, then you're going to see all the interfaces that have been added. It'll automatically add those. So you got your 2 fast Ethernet. Okay, they were there. I think I added, when I go to my config here, my physical, I added these in this slot 4. You don't need that. But this HWIC 4 ESW, this one here, if I click on it, it's 4 switching ports. And so really, when I went to my CLI and I look at these, here's these 4 switching ports right here, which you wouldn't see, but anyway, that's what got, well, of course, you start with 0, 0, 1, 2, 3, but that's the 4 of them. You wouldn't have those, but you'd have this serial interface. And you got to just make sure when you put your cursor over that little line up here, all right, that it will highlight, oops, escape. If I put it over that, it'll show you, oh, that's serial 0/1/0 that I got configured there. This one's serial 0/1/1 over here. This side over here is 0/1/0. So I gotta configure the right IP addresses on the right interfaces. But other than that, then just putting the right IP address. This one here is interesting because I have an IP address, okay, on, see, I've got 3 IP addresses. I've got an IP address on the fast Ethernet 00 that goes to my Houston network, the LAN, local area network, that 192.168.200.1. And then below it, I have 2 IP addresses. I have the serial 0/1/0. That's the connection between Portland and Houston. That's the 10.1.1.5 because the others.
So I don't think I saw us like add that the other serial ports, like the 4 extra ports.
Oh, the serial. There should just be the 2 actually. This was on mine. I don't need these. I don't need those. You know, but it's going to error because I can't do it when the power is on. But powered off, drag those off. All I really needed was this one right here. This is this baby here is what I did, and I dropped.
Yeah, I have. So I got to the point where I added that and then turned the router back on, and then it's just not working.
Okay. So now once you get that on, now you go in and configure those interfaces. So if I zoom up, you can see I got 2 serial interfaces. This is slot 1. This is slot 0, looks like. Can I zoom up any more? No. And that's where I put it. And when I go to the CLI, so it's like one, go to CLI and enable, go config, oops, show run. And I've got my fast Ethernets here. Make sure you got the correct fast Ethernet that's connected here, okay, down to your switch with the IP address for the LAN. And then when I go past that, I got here my
It's
serial.
saying no IP address now.
With your serial?
Interface fast Ethernet 00, no IP address.
Sounds like you lost your config.
Yeah, one little secret is that you can do it from the command line here, Control C, but you can do copy, running config, startup config, and it saves it. You can just do a write command like that. It'll do the same thing, but it saves a permanent version of it so that you don't lose it. Because right now, when you just do all these configurations, I know they take immediate, they're immediately active, whatever you throw in here, but it's just in RAM memory. It's not in non-volatile RAM, NVRAM. So it's not saved in a permanent area of memory. And so if you just power it off, power it on, or you come back into Packet Tracer, it literally is just like if you powered off a real router, it would just lose its config because it's just running in memory. It's like if you don't save your Word doc and you just exit out. Of course, Word says, hey, do you want to save this? But with a router, it just powers off because you just hit the power switch. So you've lost your config. So you do have to reconfigure those and then save it. Another way to save it, though, is under this config tab. There is this NVRAM, non-volatile RAM, and you can do save right there. Save, and it actually says save running config to NVRAM. And that will save it. Do the exact same thing I just did in the CLI. So that save on NVRAM will save it permanently so that when you boot it, it reads that startup config in NVRAM, non-volatile RAM, and loads it up.
Did you notice on your config there that since you removed those 4 fast Ethernet ports, the other fast Ethernets are now shut down? So you have to issue a no shut.
I'm just even more confused because this hasn't solved anything.
Yeah, your serial's on, but oh, there you go. You turn it on.
Yeah. Okay, why don't you share your screen?
Okay. I'm not able to. Okay.
Hold on. Security, screen share. Okay, now try.
Okay, so this is what I have so far before I got stuck. So physical on the router.
Okay.
It's on, it has this, the WIC2T, and it's
Yeah.
just not connecting to anything, even though it's on.
Okay.
Right.
So
Well, first off, you get the wrong type of cable.
I haven't been able to get that far.
Yep.
Do I do this to the same?
Hit the X up there, that X button. Yeah. And then there you go. And now go down to the bottom.
Should
hit the lightning bolt.
should I add the WIC2T to this as well?
Yeah.
Okay. Wait.
You gotta make sure it's turned off. There you go.
Oh, I would have saved it first before you turn it off.
True.
Okay, that's fine. So now you've got that up. Now do the lightning bolt. You can do that one too if you want. Either way, it'll there you go. It automatically chooses. Oh, you mean serial because you've already connected your fast Ethernet. Yeah. So now go back to your config. Yeah. And make sure that when you go down to those interfaces, fast Ethernet 00, see that upper right-hand corner, it says on. You don't have a check mark on there. Okay, now go down to your serial.
These also vanished.
Yeah, you
Yeah,
gotta
you got to put in
you
that
didn't
in.
save it.
Yeah,
You didn't
you
save
didn't
it.
save
Remember
it.
that little save thing I was talking about?
I see. Is that right?
Yep.
Okay.
And that one does not need to be on because you only got one connection.
Okay.
But go down to, hold on a
Serial.
minute. Go back to where you were for just a second. And the serial, is the serial turned on? No.
Nope.
Okay, turn that on. And then add your IP address there. 10.1.1. Remember it's a 10net? 10.1.1. In this case,
1.
it was 1, right?
Yep.
And then do change that mask. Yeah, the 255, the 255.252. So do the 255 there, another 255, and then another 252. No, do a 5 there, 252, and then, sorry, yeah, and then 252. Yeah, there you go. Okay,
But if you do
now
this
you don't have to do
serial as
anything on
well?
that because you're not connected to anything on that. But go up to your config settings, global settings there. Okay, see where it says save? Save it.
Okay.
Yes. Okay, now you see how it's green now?
On
Right,
one end,
now
yeah.
it's
And I
green.
assume it's red because I haven't done the same
Yeah,
for
just
this.
do that side. So click on that one.
Okay.
And enable it and manage it. Yeah, and then throw that in. Yeah, turn that one on. Assuming that's the right one, right?
It seems to be.
Okay.
I see.
And just change that again to 255, 255, 252. Okay, now go to settings, save it. Okay, see how it's all green now?
Yeah. Okay. Thank you. That helped fix everything.
Yeah.
I didn't understand that when you turned it off. I just didn't save the configuration.
Yeah.
I'm
Now you got to put
surprised.
in the EIGRP commands.
Yeah. Now
I'm
you're.
surprised it just doesn't have an automatic like saving feature that loads the most recent.
Yeah, that
No.
would be nice, but yeah, this is like real world. It
Yeah.
doesn't save unless you want to save it.
That's very. Someone needs to make routers that do that then.
Hey, that's why network engineers make the big bucks, right, Peter?
Right. That's right.
Okay. Thank you.
Okay.
I've gotten
A lot
bit
of
by
you
it
guys
several times before, not having
Yeah.
saved.
Once you do it a couple times, then you're like, okay, I got it. But it's an easy pitfall for most of you. So
And
hopefully
then if I
everybody was watching, because just because you were dealing with it, I think everybody probably has ran into the same problem.
So, question: if I turn this off again and then I turn it back on, I can just use load to get what I had before?
No, because you could load it, but by default, it loads the startup config.
Right.
So since you saved it, if you power it off and power it back on, it will just load what you saved. And then that automatically loads. So
Oh, okay.
that's the one thing that's
And then I
automatic.
guess
Now you're thinking nothing is automatic, but
I'm
there
guessing
are a
this
few
load
things that are
button
automatic.
is for. I'm guessing this load button is for loading other startup configs you have saved
Yes.
somewhere else.
Let's
Correct.
say you had another config and you wanted to load that and you had it all saved, but had a different name instead of startup config, you could load that.
Okay, thank you. I think that's enough for now. You can get back to your screen, so I'll stop sharing.
All right, nice job. That was good. Okay. All right. So hopefully that answered some people's questions. Daniel, thank you for being the example here just to go walk through it because probably a lot of people were struggling with the same thing. Any other questions real quick on this that people got hung up on right there? I know that Gary Choi, if I share my screen now, one thing that he he thought he had it all configured, and but then he had put the wrong IP addresses on the wrong interfaces because especially this one in the middle here, Houston, when I hover over this, Okay, let me fast forward. I can click on these little double arrows at the bottom left, fast forward, and it just boots it faster. Like it says, you know what, skip ahead 2-3 minutes and just let this whole thing boot, because it will do the actual normal boot, which is a good 30 seconds or more, a minute sometimes, to boot up this and get these switches working. And you can actually just fast forward that and get it to boot. It's a simulation, so it just jumps ahead 3 minutes or whatever every time you click that fast forward. But when he clicked over here, like this is serial 010, but over here is serial 011, and he had put the wrong IP addresses on those two, so they were not talking. So you got to make sure you're configuring the correct serial interface that's part of this, WAN subnet on the right, and then that you're configuring the correct serial interface that's connecting over there to Portland for that WAN subnet, for those two connections, so they can talk and be correctly, the IP addresses are correct.
Yeah,
That's
I can tell that these can fall apart very quickly, because I emailed you about like a problem I was having like yesterday, and then I discovered that it was because of a 1 character typo
Yep.
on one of the IP addresses.
Yeah, for as smart as these things are, they only do what we say. And if we have a typo on an IP address or a subnet mask or something, then it can get thrown off. Yeah, right.
And it will absolutely let you do the wrong thing.
Yeah.
Is it the one that I submitted? Because mine doesn't say that. Oh, is it? Oh, you were referring to the last time?
Yeah, when we talk in class. Yeah.
Yeah, because I was using an automatic one, the lightning one, and then that will, like, I wouldn't say randomly, but they will automatically assign the port for you, and I didn't see that, and I just configured as it is and didn't communicate. But after that, I'm using the manual one, so I can manually assign the port instead of using that. Yeah.
Yeah. So, okay, good. Well, hopefully this was helpful. And so now let's jump into then, we have in Moodle.
Oh, actually, before we move on, I got a quick question.
Yeah.
So I have a question about the DHCP on multiple subnets, and I knew how to do it, but I kind of wonder how things would work. But I found the link. This is from Cisco website, and it says that the serial link is using SLARP, so it can do DHCP or something like that. Can you educate me about that? So this is the link I'm gonna share on the chat.
Okay.
The guy was also trying to do a DHCP over the serial port, and he couldn't make it on the comment by one of the admin. His name is Daniel. He mentioned that serial interface wouldn't work for DHCP since it's using SLARP or something like that.
I'm not sure about that. I can do some research, but I'll tell you what the secret is. Here is your DNS server over here and your DHCP server. And when I go to services on that server and I go to DHCP, I have these 3 subnets, the 250 net, which was in New York over there. Okay. And then I got the 200 net and the 100 net. And I created a range. Okay. And each of these ranges, like this one here, 250 net is 192.168, 251 is the gateway, that's the router. And then I point it to the DNS server, which is 100.2. It's always 100.2 because it's one IP address. There's only one DNS server for the entire intra-network here, your LAN and WAN from Portland, Houston to New York. They all get their IP address from one DHCP server, which is over here on the Portland network on the far left. Well, when I set up these three things, I always have the same DNS server because that's where it's got to go to. And that's the DNS that every machine needs to receive that DNS IP address. And then, of course, DNS and DHCP are the same address, but then I give it this range here. I start at 10, and then I gave it 50 addresses on this is the New York one. So you see there's 50 maximum users there. And this one, the default is 265, but you can actually just do, for example, 50 if you want, and save it, and so forth. Double click on this, throw it in, 50, and that really what it does just sets a range from 10 to 60, and that gives you 50 possible IP addresses in your pool for those ranges. It's plenty, of course. We only have just a few laptops and PCs, one printer. But anyway, but what I did is for this to work, because DHCP is a broadcast. If I'm PC3 here on Houston and I turn on, I need to get an IP address. I have to go through this router with a broadcast, a DHCP Discover broadcast. It has to go from here, it has to go over to this router, come down to the switch, and then go to this DHCP server. Well, there's an issue because each of these subnets, Portland, Houston, and New York, these local area network subnets, a router does not forward a broadcast normally. So what I did on each of these servers is I went to the CLI, and this is the other little secret that you have to do from the command line. Oops. Show running config. You can just do part of these commands and it just comes up. Is when I got down to my Ethernet, I added this line right here, IP helper address. And that is the IP address of the DHCP server and, of course, DNS. But anyway, what it says with this helper address, what that means is it says when something comes in on that fast Ethernet interface and it is a DHCP discover or offer or request or acknowledgement. There's a DORA. There's the four types of broadcast for a DHCP to get a DHCP address: discover, offer, acknowledgement, request, and no acknowledgement, DORA, like Dora the Explorer. And so it will take that broadcast and it will send it unicast. It will send it not as a broadcast over that red serial interface, but it'll send it unicast. It'll send it like as if it originated from the router. And it will send it unicast, and it'll go through Portland's router and the switch, and it'll arrive at its destination 100.2. And that will then, and then the DHCP server will respond. And then when it gets back to Houston router, it will broadcast it back out to that local area network in Houston, and PC3 will then receive all that information. It will accept the offer. So it sends back, that's the offer broadcast back. Then it sends the request, which basically acknowledges that. I picked it up, yes. So please add my PC name into DNS with that IP address. And then there's an acknowledgement back from the DHCP server. So this little helper address on the LAN interface allows this to work to allow that broadcast beyond the router to the DHCP server. So I had to put one on Houston. I don't need it on Portland because these do not go through a router to get to their DHCP server. They're good to go. They just go through the switch there. But I do have to put it on this New York router. Otherwise, New York is not also going to work. So I just put it on the fast Ethernet with this helper address, same IP address. That's the little secret right there. Does that make sense to everyone?
How do you get that set up?
If I'm in there, I
It's actually
will-
on the instruction on Google Doc. Uh on the paper.
yeah,
You can check
the
it on
assignment
step
actually
6.
has it in the assignment. So I
Okay.
just do, config from the terminal, and I change into that interface, fast Ethernet 0/0, and then I actually type in IP helper address 192. I type it in, and then adds it into that interface, and then you're good. Now, of course, once I make that change, do go to config and do save it. Save your config again, or when you're in that command line, right? When you're still in the command line, do a write or do a copy command, copy running to startup, right? And do that. One of those commands to save this thing. Otherwise, it's just a temporary assignment of the helper address to the local area network or LAN interface. Okay.
Well, thank you for the explanation, Mark. I actually made it work out, but just couldn't understand what they were saying in the link. That's why I was asking. It was working on the packet tracer, but there's a comment that the serial port doesn't support DHCP.
Gotcha.
Now, if you notice, this is the Cisco way of doing DHCP. If you remember a couple weeks back, we did the Microsoft way of doing DHCP, where you had 3 separate DHCP servers, and they talked to one another and exchanged their configuration between each other. So 6 one, half dozen the other. I prefer the Cisco method myself.
I'm
I
going to kind of
see.
put back Gary's question, but I had a little bit of different of an understanding. So I don't know, maybe at some point I'll be able to piece it. But with ARP or SLARP, you're talking about address resolution protocol, which I understood that it basically was able to convert and find out what an MAC was, or it went to the higher level of approaching how you maybe exchange an assignment for IPv6. And when you're talking about DHCP, that was a generalized term that meant that you can have something designated as a DHCP entity, which will then dynamically assign your addresses. So you're kind of talking about an apple and an orange, where one may be trying to figure out the MAC and the other is the title. So you could technically put ARP and DHCP together, but I'm not sure that it would work, as Gary said, because I think you may be looking at something that trickles into using the IPv6 protocols more, but to me, this DHCP simply meant that that's who was going to get to assign protocols within, as you said, Mark, within a range to have them dynamically assigned. So,
Okay, well, let's step back a minute, because address resolution protocol is only with IP version 4. Okay. And it is a table
okay,
and it uses broadcast, and there's no broadcast in IP version 6. They use neighbor discovery, and it's a multicast. But anyway,
okay,
with IP version 4, if I'm PC3, or let's say I'm PC1, this is more interesting, and I send out an ARP broadcast, okay, my whole subnet gets that. But the router blocks the ARP right there at the end of that LAN segment, that 192.168.100 net. But everybody responds back and says, hey, here's my IP address and here's my MAC address.
okay,
And the address resolution is MAC address to IP address. So it creates a table in those 2 laptops and the PCs and the servers. They all have a table, an address resolution protocol table that says MAC address associates with this IP address. And
right.
so by that broadcast, everyone broadcasts back, which means everyone gets their packet, and they all build this table, and it says, okay, now I know about all the other IP addresses and their associated MAC addresses through that ARP broadcast. And so that's a periodic thing that gets sent across the local area network. And it also gets built on the router. The router also has an ARP table as well for MAC to IP address. For everything that's come through the router, it builds it as packets are traverse the intranet there. Peter, you want to add anything to that?
Yeah, because of all the broadcasting with DHCP and ARP on an version 4 network, you want to try to keep your subnets fairly small. I've heard recommendations of 512 machines, although modern equipment you can do more like 1,000 or 2,000 machines, but no more than that on a subnet, because your broadcast will get too much and it will overload the network or overload your devices.
I appreciate that kind of clears that up, because the SLARP is a very simplistic, obviously, system between two routers. But as Mark obviously pointed out, the ARP just by itself is a term that would only reflect those subnets in an IPv4 requirement to the MAC. So I that's perfect. That kind of clears up some smoke there.
Okay.
Also, can I share one thing real quick? That I found out the function called simulation you see on the right bottom side, and then that actually helped me a lot understanding how packet going back and forth.
This simulation here?
Yeah. So for example, if I want to learn about DHCP, let's turn on the PC3 if you don't mind, and go to config, and go to just click DHCP there. Boom, now you send the packet and you can exit that out. And
Yeah, I should have had that already. So
but you can see how thing will work from now. And then all you
you want to see this, you mean?
yeah, so go to the edit filter on the left bottom side,
Oh, mhm.
and then remove everything but DHCP. Oh, actually, matter of fact, I'm sorry. Can you exit it out? There is a show all and none. Click that first, and then go to the edit filter.
Show all?
Yeah, click that. Then it'll going to be none, and edit filter again.
Okay.
Go to DHCP. I'm looking for DHCP only, and
Okay.
then exit it out.
Okay, all right.
Or yeah, and from there go to PC3 again,
Okay, PC3, yeah.
and DHCP click once more.
Like that?
Yeah. Now you see there is a simulation site. You see the DHCP is on. Don't exit it out. Just minimize it.
Okay.
And then now what you do is you see the little envelope on the PC3. Those are the packet that as soon as you request for DHCP, that's generating from the PC3. Now all you have to do is there's a play control on the bottom. You can I click fast forward. Just click fast forward to move how packet go through, like that. So that was really helping me understanding how things actually working. This is only for DHCP, but you can do all the other internet packets. I try to go to the DNS server from the internet on the PC3, and it'll going to go back and forth how to communicate. So now the PC3 went all the way down to DHCP and went back. Now it's configured. And you can actually see every single packet, how it looks like by just double clicking the tab on the top.
Up here?
Yeah, any just double click the tab, any tab. Yeah, any
What
rows.
do you mean?
Any rows would be okay. Yeah, just double click that.
Okay, yeah. Okay. Like that?
Yeah, like that. Then what's included, what you receive, or how the DHCP server responded back. Or you can simply double click that envelope too if you want. What will be the destination, and where's the internal layer and everything. So I felt it was really interesting. I wanted to share with everybody. So,
Yeah, it's kind of like a Wireshark.
yeah, exactly. That's how I felt.
Yep.
But on the Cisco version.
Cool.
So it was if you actually reset the simulation again, there's a little button on the left middle side. Yeah,
Oh,
reset simulation, and then you can try it again, but this time you can see the how envelope or packet is going through. So once you
So just do DHCP here,
yeah,
okay?
mhm.
And
It-
then
we can do PC4 if you want, any of them.
PC forwarding, what do you mean?
Oh, no, you don't have to do since we already did a PC3, we can do PC4. That's what I meant.
Oh, I see.
Yeah.
No, I
PC2,
think
yep.
what? Okay. PC4 and config
Mhm.
and go to static and then go to back to DHCP.
Mhm. Now
Okay.
you see the envelope down there. And then you can fast forward from there.
So it broadcasts it to everyone there.
So before you click that, just double click the envelope in the router right now.
Right here.
Yeah. Now, so this is the one that you're shooting first. That it was from, you don't know the source IP address because you haven't get assigned yet, and then you are looking for the destination IP address of 100.2. You see on the out layers.
Yeah, layer 7 DHCP packet service. It's all zeros because it doesn't have one yet. Client is 0.
Mhm.
Destination is the all
Oh, not there, on the out layers on the right side of the packet.
out layers. Okay.
Yeah, and the layer 3 it says destination IP address is for the DNS server where you which you assign to.
Yeah.
So
That's how it transforms a packet for you. Yep.
yeah, so that's your destination for that packet. So the packet will go looking for that IP address. So it'll just broadcast everywhere until they find that 100.2 in the internet in the network.
Mm-hmm.
And then you can fast forward again up until you hit the DHCP and double click the packet again. Now you see the packet has arrived, so there will going to be no out layer since this arrives, and the next fast forward will show you, oh, this is the IP address that you're going to get, and blah blah blah. It's also in that packet too. So now it arrives at the DHCP server. So you see that there is no out layers because it arrives at this destination. And now it says, hey, this is the source, and I'm going, oh, if when you click one more fast forward, it'll going to assign the destination back to the PC4, and it'll contain the IP address that we're going to assign from DHCP.
Oh, one more.
Yep. And then click the switch one. So that is the response from DHCP server to the PC4.
Yeah. So now it has a broadcast back.
To
It hasn't. It's still layer 2 because at the switch. If I go one more, now it's at the Portland router. Now if I click that, now it's at layer 3. And here, source address is 251.1, or sorry, 250.1.
oh, actually, click the outbound PDU detail. That's where I found it. Yeah, and go scroll down. There is a DHCP, and you see the client address. So this is where you get the where the packet contain or pertain the IP address for the client. So the PC4 currently doesn't have IP address because it hasn't been assigned yet, but that IP address is inside of the outbound PDU details.
Mm-hmm.
It's the offer. Yep.
Yeah, the
Now
offer
this
is
is
down
the offer, which gives it, here's your IP address that I'm going to give you, 250.11.
there.
Server address 100.2, which is you're going to assign as, hey, now you know who the DHCP, well, this is the DNS server,
Mhm.
and there's no relay agent. And yeah, this is
Yeah.
all the packet
Mhm.
information there. Yeah. Yeah. Yeah, that's cool walking it through step by step with the packets. Okay, cool. All right. So we have, it's talking about dynamic. Yes, should have this packet tracer install instructions, should have everything you need. If not, let me know. Hopefully we're answering questions that maybe weren't as instructed as well in here. And another thing is week 8, which is, am I in the right? Yeah. Okay, week 8, which is coming up, which is the next week. Just want to, before we run out of time, I want to make sure we got a half hour, but okay. Your research paper abstract is due. That's halfway through the class, 8 weeks out of 16. So give me your paragraph on what your research paper is going to be about and submit it right here. And that is due on the 11th. So next week. So 2 Thursdays from now, that'll be due. Also, your final paper right here, research paper, will be due. If I click on that, it shows I had the wrong, I still have the wrong due date in there. Why is that? It should be due date. All right, let's try this again. April 29th. So April 29th, okay, is the second to last week of our class, because that week of the 3rd through the 7th, that's your finals week. And our final exam will be on the 4th of May. Okay, so that Thursday before is the 29th of April. And that now should save. And okay.
There it goes. Okay.
So that is then due then. And your final exam then will be that 4th of May. All right. Okay. All right, right there. All right. Okay. Along with that is week there. This week, March 1st to 7th, it says dynamic routing protocols. Okay. So save that and open it up. Let me do it. So all right, so there's a difference at the top here. It needs to be explained at the very beginning. Routed versus routing protocol. All right. So a routed protocol directs network traffic using network headers with packets. Okay, whether that's Ethernet, like an Ethernet packet. That has a source and destination IP and MAC address, and it helps data get from one place to another. But a routing protocol, all right, those maintain and update routing tables between routers. So this thing that we talked about, EIGRP, okay, it's down here, right here. Okay, EIGRP is a Cisco proprietary, okay, routing protocol, and it keeps a table of, it understands when we're showing that packet tracer, it's defining, okay, I know how to get to router Portland router. I have to go through Houston. From New York, I got to go to Houston, and then I got to go to Portland. That's how I get to Portland. And it creates that table, a routing table with how to get to specific networks. So it knows to get to its own network. Okay, it's local area network, and then its wide area network goes across that serial interface, the red interface, to Houston. And Houston, of course, it passes its information about its connected LAN and its other connected WAN back to New York. And then also Portland passes its information with its connected LAN in Portland, local area network in Portland, back to Houston. Houston then passes that on to New York. And so these three routers share information amongst each other based on what type of dynamic routing protocol you're using. Now, these are what are called interior routing protocols. OSPF is open shortest path first. It's a link state protocol. It supports VLSM, variable length subnet masks. IGRP is interior gateway routing protocol, proprietary Cisco distance vector, developed to overcome RIP shortcomings. So, and then of course the predecessor, the next gen, is enhanced interior gateway routing protocol, also proprietary Cisco, and they call it a balanced distance vector. Okay, what do those mean? And we saw RIP, routing information protocol. And then there's some other ones, so some external or exterior routing protocols. And this is, there is, in fact, I have a, all right, I have an updated version of this, but I'll talk about, okay. So let's go to the top and explain what this all means, okay, in your doc. Okay. What is an autonomous system? Okay, an autonomous system, think of it as like a group. Many times it's a geographic group, but it's a set of routers on the internet that are part of a group of routers to share routing tables. And so they're all using BGP, Border Gateway Protocol on the internet. They all share that in an autonomous system. All right. So a logical or a group of an internetwork under administrative control. Okay. They'll share information with a routing protocol. And so they share amongst themselves. Then there is a router on the edge. Okay. In fact, where's my updated version of this? Okay. All right. Okay, let's open this one up again. So open it up from had a little typo that I want to fix. So open up the new one that's now on there. And let's do page width. Okay. Okay. So, all right. So now we had, when we put in that EIGRP, it had its own autonomous system. I put 100, it could have been 1 or whatever, but so long as those 3 routers are part of the same autonomous system, it was router EIGRP, okay, 100. That was the autonomous system number. And then it shared the routes on that router amongst the other routers, because the other routers are like, look, I'm in Portland and all I see is my connected LAN and I see a connection to Houston. That's it. But Houston says, okay, I've got a connected local area network, 192.168.200 net. But you can't see that because I'm not sharing that with you. But now when you use that router EIGRP 100, Houston shares its 200 net, and then it's shared between New York and Portland. And so they're aware of it. So that now in Portland, it says, if I want to get to the 200 net, I have to go through my serial interface through the WAN over to Houston. And then I know that the 200 net is directly connected to the fast Ethernet of Houston. And that's how I get a packet from Portland over to that local area network in Houston down to PC3 or 4. And so they all have to be a part of the same number, which is this group that shares routing information. And by putting routers into these different groups in the internet, every router doesn't need to know the route to every other router, but they share tables within their groups. And when it's outside of their group, then they can send it to a border router, an exterior router, and it will then pass information. It knows information to other autonomous systems that it connects to. So autonomous systems connect to each other through a border router, okay? And so normally it's interior border gateway protocol within the autonomous system, and then it's exterior border gateway protocol when a router is on the border of one autonomous system. It'll exchange all the information from one system and it'll give it to another system border router so that you can share routing information between systems. But this way, if you're just a router inside one of these autonomous systems, you don't have to know about the route to every router in the world. You just have to know about it within your group. Peter, you want to add into that?
Not really. I think
Okay.
you got it pretty well covered there.
Okay, let's talk about these routing protocol classifications. Okay. First was distance vector. And it updates every 30 to 90 seconds. The router information protocol updates every 30 seconds and the IGRP every 90 seconds. it passes the entire routing table to every other known router. Okay. And then it has the RIP was 15 hops. Okay, and that's as far as it could go. 15 connections to your end destination. You know, hop 16, every hop is a router. If you got 16 routers to get to your destination, it didn't have a big enough routing table to store all that information, just 15. Okay. And okay, now came link state. It understands entire network topology plus connection speed. So it's smarter. Okay, it's not just number of hops. If I need 2 hop, distance vector is if it's 3 hops or 3 routers to go this way, but 2 routers to go this way to the same destination, I'm going to go the 2 hop route. But it could be that those 2 hops have slower WAN links. The bandwidth is less, or there's more congestion, or so it technically is slower through 2 router connections versus 3 router connections. But now comes link state, and it understands the topology plus connection speeds. Oh, this is a high bandwidth connection. Okay, I'm going to go this route. Okay. Also, the updates between routers is not the entire routing table every time. Like with RIP, it was this routing information protocol. It was every 30 seconds you sent the whole route table, but now it is updates only when there is a change. So it's just going to update it only when there's a change. Like let's say one of these links goes down. Then you've got to update. Okay. And they said the link state does hello packets and just says, hey, you still there? You still there? And it understands all routers in the topology and shortest path first algorithm computes best routes based on available bandwidth and congestion. So it's more accurate. All right. Then now, of course, this is more information that the router needs to store. So it needs to have a bigger processor and more memory. But all major routers, modern routers, have enough processing and memory to manage a link state type route, dynamic routing algorithm. All right. And then when a new router comes online, it floods the network with those hello packets or those LSPs. After that, only every 2 hours, on average up to 12 hours, just to make sure all the routes are still there. Okay, then there is balanced hybrid. It's like the best of both worlds. It's more efficient link state protocol, which is what we just talked about. Mitigates increased use of processing, memory, and bandwidth. So it's better, more efficient, not as much processing and memory. So now we've got these here, OSPF, link state, IGRP distance vector. That was the first one, okay. And then EIGRP is what they call balanced. I think maybe it should be balanced hybrid actually, but anyway, it says balanced distance vector. And this is the distance vector RIP2. I should put that actually at the top. This is an older one, probably I think the very first one here, but it should be up here at the top. Yeah. Then came, these are your distance vector. The first one's out. Then these OSPF, EIGRP. Okay. So these are all dynamically, basically all these are dynamically providing routing tables and learning about the next hops or the next routers in line so that they can route a packet to its final destination. And this is basically these routing protocols, IGRP, RIP, OSPF, EIGRP, they're all used to create these tables to allow for routes to be created.
Mark, I have a quick question for you.
Yeah.
In describing like those LSPs where it might take from 2 hours to 12, my first thought was, okay, you're talking about maybe how big the network would be. Obviously, in larger networks, and you're adding, say, a whole array of routers, or it's learning. Does that establish in my mind the idea that it has to get feedback or proof that all routers have now gotten the new table information? Is there some metric that says we're good to go, that the update is complete? I don't know how that part works.
So well, what happens is this is just pulling information together originally, but now it gets the routing information very quickly. But then it's just verifying that every 2 hours just to make sure you're still there. You're still there. Hello, packet. You're still there. You know. But if something goes down, okay, this is what's called convergence time. Okay, convergence. Okay. Then convergence is when a link goes down, and it says, hey, I cannot get to Houston through Portland. Let's say there was Toronto, and Toronto was up above, and so it was like a square. So Portland could go to Toronto and then New York, you know, if you had one more router in there, and you had multiple paths, maybe Toronto and then New York. Well, if you have that, okay, you can still get to New York. In our little scenario with our 3 routers, if the link goes down between Portland and Houston, you're out of luck. You cannot make it. You can't get to New York. Okay, New York and Houston can still talk, but Portland is down for both Houston and New York. All right. So when a routing link drops, all routers must be informed to update their routing tables. It is the time needed for all routers. Okay, I'll just say convergence. It's the time needed for all routers to update their route tables. No data is passed during this time. Once converged, all routers are operating with the same routing information. So really, when this convergence happens, you literally stop routing, okay? And it says, hold up, there was a link. It's send me your route tables, update it, then start routing again. All right. And it's and how this works is, in our case, we only had 3 routers, okay? But let's say we had another router, okay? All right, let's say we have another router up here. All right. And this router you had a connection to, right? And then I did my lightning bolt. Oops. Oh no. Lightning bolt. Okay. So now this is Toronto. Okay. So now I got Toronto here. So Toronto is right here. Now I can go from Portland through Toronto to New York, or to get to New York, I can go through Houston and then New York to New York. I can go two ways. So let's say we had this scenario, and this is better because if one of these fails to Portland, okay, I can still get it. Let's say this one fails right here. Okay. Let's say that goes down. Okay. Portland can still route to Houston, New York, and then up from New York to Toronto. And so packets can still get to Toronto from Portland through two other routers. Okay, it doesn't have a direct connection now, but you can still send data down through Houston and then to New York and then to Toronto. And Toronto can do the same thing. So you're not totally down, all right, with this type of scenario. All right, you can reroute. But if that link goes down, there's convergence. All these four routers stop and they go, oh, look, there's a link down between Portland router and Toronto router. And therefore, the new route has to be updated to say, if I'm Portland, my route table's got to be updated to say, for me to get to Toronto, I have to go through this serial interface over to Houston, and then Houston to New York, and then up to Toronto. That's how I get to Toronto now. Not directly, because my link is down. And so they stop, they share route tables again, they update with their route minus the route that went down, and then they start routing packets again. That's convergence. Does that make sense?
Yeah, that kills two birds with one stone, especially regarding question about the metric and how they say we're good to go. So yeah, thank you. That does. You have time for another really quick question? With you guys teaching about the Cisco stuff, is there any need for us to pursue any of the competitors of Cisco? There's a couple of protocols that you've mentioned with the EIGRP and so on that might be proprietary. Are other competitors using just simple knockoffs of those same versions to stay competitive that you know of?
They're using OSPF. That's the industry standard one.
Okay.
Yeah, if you go down to
Or
this,
BGP.
I didn't mention it, but this shortest path first is open source. Okay, it is, I should have put in here non-proprietary.
Yeah.
Okay, so this is meaning that people can use OSPF and you don't have to pay some licensing fee to Cisco. You can use it. It can be used by anyone in their routers, and therefore it's probably the most utilized within a local area network. If you're not using Cisco, if you're all Cisco, then use EIGRP because it actually is the fastest and the best. And well, that's what they say. But other than that, if you're using different types of routers, you can use throughout your local area network, you can use OSPF and share links. OSPF, EIGRP, IGRP, and RIP, and so forth. These are used in a local area network. And then these are interior. Then these exterior routing protocols here are used on the internet. Okay. and IBGP or EBGP, interior exterior border gateway protocol. It is a distance vector. Okay, guess I should do okay, and to be consistent, distance vector, and it's used on the internet. Okay, there's another one here, exterior gateway protocol, but it's not used like this. This is really, do you know of anywhere where EGP is used?
Not that I know of.
Yeah.
Everybody uses eBGP,
Yeah.
and it doesn't converge very quickly, but it's like a big pickup truck. It can carry the entire internet routing table in it.
Yeah.
So in other words, it knows where everything's at. Whereas OSPF or EIGRP would, the routing table would just be humongous if you tried to put that on the internet. It wouldn't be able to do it. So everybody uses BGP instead for internet.
Yeah. So this EBGP would have or IGBT and E would be part of an autonomous system, its own autonomous system for just BGP. And then EIGRP, we put into our router for our routing protocol between our three routers that has its own autonomous system. So you can have multiple dynamic routing protocols with their own autonomous systems, keeping separate routing tables, one EIGRP, one BGP, okay? So just be aware of that these have their own routing tables and so forth, independent of these other dynamic routing protocols. Okay. All right. Okay, so we're out of time. We'll pick this up and continue on with what we're talking about and add to this on Thursday.
Yep.
But just be thinking about your paper, write up your abstract. If you want to talk about your paper topic with myself or Peter, send us an email and see if this is good. We can give you some feedback on your topic if you'd like. And but then write up a paragraph that's going to talk about what you're going to talk about, what are the key elements, what things are you going to, what's the future of it, how is this, affecting the, for good or bad, the networking community, things like that. All the things you're going to talk about, lay that out in a nice, succinct paragraph or two. Okay.